Right, hello everyone and welcome back to another CRT stream, and today of course we're going to be talking about TCT, or TCT Show, because TCT is some transcatheter something strange, so yes, it's definitely TCT Show and not just TCT. So day one has been fairly interesting. There's a lot there. The room is obviously pretty big, but it seems to be divided kind of into a consumer side and an industrial side. So on one end you've got all these people dressed super smart showing off their really expensive machines, but there's not many people that are hugely interested in that, so it's quite empty down that end of the room. But down the other end, where you've got the kind of more consumer side like E3D and Prusa and that sort of group, there seems to be a lot more activity and there's a lot of interesting stuff going on. So just as a precursor to today's stream, it's not going to be super high quality. I am literally in a kind of rented room while I'm up in Birmingham for the show, using a laptop which has not been used in sort of 8 years, and the webcam's not exactly great, the lighting condition is not great, the microphone is the normal microphone, but there's not going to be anything too special going on. So if you're expecting something super high quality, then that's not what this is going to be. This is going to be me going through hopefully a bunch of images that I've taken and showing you what I saw and what was interesting about what I saw. So just to give you an idea of what we're going over today, we're going to start with a company called 3D Evo, who I talked to as soon as I got there, not because I rushed to them, but I was kind of looking around and what was on their stand was fairly interesting to me, so we'll take a look at that. And then Fillamentum, and then Ooznest, ColorFab, and RepRap World. Now RepRap World have something really pretty special, I think. That is going to be super interesting, so we'll get to that last. But that is really, I think it's going to be really, really good. As soon as I saw it, and the guy over there, Bart, who was talking to me about it, I was just like, this is going to be good. So yeah, we'll get to that in a minute. But first, let's go with 3D Evo. Hello, Wolfram. Nice to see you. As we go along, let me know if you have any questions. I mean, obviously, I've kind of been introduced to a lot of these things just today, so I'm not necessarily going to know huge amounts of information about them. So you'll have to bear with me probably. I've written down a whole bunch of stuff, and I can probably remember a fair bit about what was talked about, but there might be some gaps missing. I have also actually spoken to Prusa today, not Joseph Prusa, but part of the Prusa team. There's quite a lot of interesting stuff going on there, obviously, with the SL1 and also the Filament. But I'll probably cover that tomorrow after I had a little bit more time to talk to them and go through the details. Hello, Kim. Okay. So, 3D Evo. Let's go over to, I mean, you don't need to see me the whole time. So let's go over to the slideshow where we can take a look at what was happening. So, what you can see here is a bit like a fill extruder. It's basically a filament extruder. Well, takes in particles, heats it up, has a little dial on the front, and you sort of select the temperature zones because you have to have like a gradual melt as it goes through what I presume is a standard kind of, not a standard part, but a Archimedes screw, as is typically used in an extrusion setup like this. And you can see down the right hand side with the panel open where the filament comes down around the thing at the bottom and then off onto the spool. The filament is cooled by those two fans at the top. I don't know if I have any slightly better images of it. No, that's probably the best one as we were. And they're kind of two big radial fans that blow inwards at the filament and keep it cool as that's all running. Complexity wise, it didn't seem very complicated. I mean, all the parts are kind of fairly simple, the kind of stuff you'd expect to see in a machine like this. I didn't look any further inside of it than what you can see here, so it's not been torn down or anything, so I don't know all the details of what's inside, but it is a fairly premium machine. It's not necessarily, although I'm obviously talking about it because some of you may be interested, it's more like the thing that you'd buy for a makerspace or a university where you do some 3D printing work, rather than for your own home use, because there's probably not that many people that could afford it. I don't know the exact price, I didn't ask, but I was told it's definitely on the expensive side of things. So if you're in a group where you can afford a purchase for doing recycling and that sort of thing, then this is the kind of thing you want. In terms of filament that it can deal with, they did say pretty much anything. So even stuff that's soft like TPU, it can do that. Stuff that's really expensive and hot like PEEK, you can do that. So it's pretty much the full range of materials. You might get a bit stuck on super soft materials, but in general, like 95% of filaments should be fine. In this picture you can see the little hopper that sits on top. So I did ask them kind of how long they expect these machines to run for in terms of kind of duty cycle. So if you don't know what duty cycle is, it's kind of the amount of time you expect something to be operating. So for an industrial product, you might expect that to be 24/7. You turn it on, it just runs and runs and runs and runs and runs and runs until something breaks. Whereas if it's a consumer product, you might expect it only to run for like 2 hours a day. But this filament machine can run pretty much 24/7, as long as you can keep the hopper filled. You might have to add additional hopper space on top, but that shouldn't be too much of an issue, I don't think. Just want to check if the audio is okay. It sounds okay. Presumably I've had no complaints, so if it is not great or if I'm too quiet, let me know. So here you can just see a little bit closer in the base of the unit about what's going on in there. Fairly standard 3D printer components really. You've got a stepper motor with a lead screw with a lead nut that controls the filament direction. Filament direction? Yeah, kind of it controls the manner in which it spools onto the spool. And then you've got a rail that just kind of guides that. How about speed? I didn't actually ask about speed. I mean, it wasn't operating very quickly. Yeah, it's pretty slow. But yeah, I didn't ask about speed. I'll see if I can get to them tomorrow. I mean, they told me like speeds of the other machine, but not in terms of quantity feed rate. Sorry, just taking a couple of notes so I can ask them tomorrow. Because obviously I'm here for a few days, so if you have any questions that I can go back to them with, then I can do that. So this product does actually come in a pair. Oh, we'll get to it in a minute. Oops, that one's kind of sideways. Sorry about that. I've not had much time to edit these in any way. But there you can kind of see the spool sitting in the middle. It's not super quick to change the spool because that nut on the front, you kind of have to wind all the way off by the looks of it. And that's just a basic display on the top to control your temperatures and things. This is the kind of brother-sister relationship. So this is the, I can't remember what they call it, crusher, grinder. It basically obliterates anything plastic into stuff that you can put into the other machine, which looked pretty dandy. You can see a kind of chute in the top where you can put either your own prints in or other materials. So for example, plastic bottles. They did mention that they actually supply their machines to the Ministry of Defence in the Netherlands to recycle plastic bottles because they only use them once, so they have to destroy them and recycle them. So they wanted to let me know that they supply to that. So that's the kind of industrial partners that they work with. So on this image you can see obviously that chute at the top, as I've already mentioned. The output at the bottom, there's a little panel there that has to be closed in order for it to operate, and in there is just a little bucket. Someone during the moving of this from their business house to here lost the little hopper that's supposed to sit in that hopper, like the receiver, little bucket that connects with the plastic. So that was not there. But I mean, you could clearly see the machine works. They've had this out for I think it was more than a year, maybe a couple of years. So it's a fairly well developed machine. The whole thing is driven by an electric motor which is about 1 horsepower, which doesn't sound like a lot in kind of car terms, but in terms of electrical motors and size, that's pretty massive. So in this machine, if we go to the next, maybe a couple of images here, you can see, so that in here, you've got that top rotated off, so you can see the hopper out the right hand side of the picture, and then you can see the grinder mechanism in the top, and there's a secondary grinder or cutter, mashing, whatever, slicer, dicer kind of mechanism in the base of the picture. Now it goes in 2 parts, because one of them, the top part, basically takes something fairly whole, like an entire printed part, and will crush it down into just something smaller, generic sized. The parts at the bottom is kind of a spinning blade that will cut and cut and cut things until they fall through the little filter that's below. Filter the right word? Yeah, it's kind of like a mesh. So if it was, the mesh will basically determine the size of the particles that get through. The bigger the mesh, the more gets through at a larger size. So yeah, quite industrial piece of kit, but quite impressive nonetheless. You can see there all the kind of mechanisms sitting together. All fairly nice. So that was a nice piece of kit. The control on the top is really quite basic. It's literally kind of go, stop, forward, reverse kind of thing. You only need to reverse if it's if something gets stuck. It normally doesn't jam, but the plastic can get stuck, kind of gripped around the teeth mechanism. So you just reverse it briefly and then it carries on. Now this machine you can't actually run 24/7 because of it's a lot of power. So it's not that quiet, but it also generates quite a bit of heat. So over time that heat will build up, and all this plastic that kind of sits around and falls through this mechanism will end up being kind of toothpaste-like. It all gets stuck to each other in a fairly unpleasant way, and which is not particularly ideal, but it doesn't take long to cool down. I think he said somewhere in the region of 48 hours of operation. You might need to let it rest for half an hour or so just to let it cool down, so your plastic doesn't all go all molten. It obviously is dependent on what you're crushing down and what temperature will affect it. Has like an emergency stop, it's all CE compliant and all that sort of stuff, so it's a proper quality piece of kit. Very nice. Now I think we might be out of pictures. Yep, so that's back to 1. So if I now move on to the next company, so I have to just change a couple of settings here. So let's move on to Fillamentum, I think. So Fillamentum had a couple of things to show off. Filaments, of course. I'd expect nothing less from Fillamentum. I do often get Fillamentum and Fillamentif mixed up. Fillamentif are the UK company that do all sorts of recycled, basically recycled everything, or bio, polycarbonates, stuff like that. And this is Fillamentum. Slightly different company, slightly different location. So, hello Zoomtronic. Good to see you. So yes, Fillamentum had 2 things to show off. Let me just find my notes on this. You've got this vinyl 303 and then something with a really not very catchy name. The CPE HD100. So vinyl 303, I mean vinyl is a really confusing name because typically if you just use the word vinyl, people expect it to be a kind of sticky backed tape sort of arrangement. And obviously it's not that. So PVC is sort of a polyvinyl chloride, which is what this material is basically. In terms of heat resistance, it's about 71 degrees Celsius. You can see they've got that little data sheet on the desk there. So nothing too extreme. Nozzle is required to be 215 to 230 with an ATC bed, so nothing too extreme for being able to print it, but it is worth noting that there are harmful vapors when printing it, so probably not the best for home use unless you've got filtration and that sort of thing. And apparently the vapors can also affect stainless steel, So that sounds interesting. Don't know much about that, but hi Tyler. No worries. Ah, good to see you. So this filament prints it seems very general filament, kind of 40 to 60 millimeter second print speed, fairly average nozzle temperatures, bed requirements. One thing that it's fairly good though is it does have a low moisture absorption, so that it's not hygroscopic, it's more hydrophobic. So when we're using things like nylon, we tend to have challenges with keeping it dry, because otherwise when it gets wet you get all the steam and stuff when you're trying to print it, and you end up with terrible quality, or even worse than that, it's so brittle that it just doesn't really print very well. I've actually got those data sheets with me, data sheets. So tensile strength, they've rated it at 46.1 megapascals, hardness of 78, and that's Shaw D type hardness. Thermal stability of greater than 40 minutes at 200 C. Not really sure what that's all about, because the heat resistance is the 71C. Not sure how thermal stability at 200C kind of works, because if you're printing it at 215, I can't imagine it's solid at 200 for 40 minutes. So I mean, one problem I kind of do have with their data sheets is that they're not very comparative. So for example, let me go back to this quickly in my dark room. It's actually not as dark as it appears, but you see how down this side, you probably can't see in huge detail, but down this side there's like a list of properties basically, but they're not very specific. So let's just, oh, there we go. Now you can see it. So it just says excellent printing properties, strong interlayer and bed adhesion. Strong, how strong and what bed adhesion? Mechanical properties of tensile strength, hardness and impact resistance. I mean, everything has a tensile strength, but what is the tensile strength? Well, I know it says on the other side, but like what it also says hardness. It doesn't measure impact resistance. It's just it's a weird way to put it. But it does have, it says chemical resistance, low moisture absorption, ROHS compliant, which should be fairly simple. Fairly good heat stability, good mechanical properties, excellent printing properties, strong interlayer and bed adhesion. So that's obviously, when I talked to them, they were basically saying this is a good printer, good filament for prototyping. And it's all in like nasty colours, which didn't help anything. Commodity plastic available in the form of filament. So yeah, fairly interesting little material. If it's as toxic as the subtext implies, then maybe not great for home use, but still interesting nonetheless. They had no pricing information, I'm afraid. I'll see if I can get some tomorrow. I didn't actually, I didn't ask prices much on anything as I went around, because a lot of this stuff that's like brand new, the price is not necessarily set, but so yeah, that's the vinyl 303, and the second one is this lot printed here. So this is the CPE HD 100. This was a little bit more interesting. So this is based on PETG, but it has some modifiers that apparently make it better in every single regard, which seems unlikely. But I mean, the numbers kind of stack up. Again, I got that data sheet that you can see on the desk there in the picture. So it implies that it has no breaking impact resistance. I mean, presumably that's just in their specific test. It wasn't able to break it. So, I mean, it's strange to have no breakage, but it's basically implying that it has better impact resistance than PETG. The tensile strength is also listed as being better. The hardness is rated as being harder. I'm not sure what R scale is for hardness, but that's what they've listed it as. Basically, they're just saying it's harder overall. Has 10 degrees better heat resistance. I mean, they've listed PETG as 70 degrees C heat resistance. Typically, I would assume that PETG is nearer to kind of 85. So the fact that the CPE HG100 is 80C makes me think that actually it's probably lower. But, I mean, that remains to be tested. And then better chemical resistance of this HG100 versus PETG. So as similar to PETG, good interlayer adhesion. It's fairly easy to print. There's no odor and there's pretty low warping. So, I mean, in terms of ease of printing, it's pretty high on the scale. Although you do need a nozzle temperature of 255 to 275 and a bed of 70 to 85. The bed is less of a challenge, but 255 to 275 on some nozzles could be difficult unless you're all metal, in which case it shouldn't be too much of a problem. It does say that due to strong adhesion to the other materials, plastics, composites and glass, it can damage your bed without adhesive. So they want you to put Magic Glue on. They want you to put Magic Glue on everything, I think. Sorry, I've just paused because YouTube's complaining that there's not enough data going through, but there doesn't seem to be an actual issue. So I shall carry on and ignore it. It says zero dropped foam, so. It does also say safe for food contact applications. Can be used in contact with food up to 100 degrees Celsius, that is. So that's quite interesting. Obviously, that's going to be impacted by the way you print it. If you're printing it with gooey nozzle that has all sorts of other stuff on it, then maybe not the best thing, but there you go. Now, this is also worth noting that, let's switch back over to here. So Fillamentum have started using this Fillamentum industrial label. So their Fillamentum industrial range is going to be this kind of stuff. It's going to be kind of more industry-based materials, engineering materials, if you like, prototyping things, rather than lots of pretty colours of PLA, which look nice, but maybe functionally aren't that useful. I mean, PLA has its uses, don't get me wrong, but a lot of what we see for PLA is just lots of colours. So here they're putting the focus on kind of professional applications, which is fine. I've got a couple of samples. I mean, they're not exactly extensive, so I'm not sure how much I'm going to be able to do with them. I mean, they're pretty small, and they probably need drying as well first, but nonetheless, they are there. Okie dokie. So yeah, those were the two things that Fillamentum wanted to talk about. Look pretty interesting, and perhaps we'll get through to those. I'll start using them at some point. They printed all sorts of little things on the desk out of these new materials. Nothing particularly incredible. Kind of stuff you will have seen before, I would imagine. You can see all this vinyl 303 in this strange light beige sort of colour. It's not particularly attractive, but for prototyping it's kind of accepted, I believe. I'm not sure why there's this one black part in the middle. I don't know if this vinyl 303 must come in black because it shows black on the data sheet. So presumably it comes in this black or natural colours. And I think we're cycling now, so let's go on to the next one. Allow me 2 minutes while I change the photos to the next set. Oh, that's not worked. Oh dear, I think it might be dying. Nope. So, what else are we going to look at? I've forgotten what was on the list to do. Repro will do last because that has definitely the coolest thing. Ooznest. Let's have a quick look at Ooznest. So spent a little while at Ooznest talking with Ryan and James. Oh, please don't say it. I'm pretty sure it's James. Yeah, Fordham. You'll know him as Jay's 3D Adventure, his YouTube channel. But yeah, he works for Ooznest. So I had a good chat about them, about what they're up to. They've got a couple of cool things on their stand, like this. They've got this Workbee CNC. This one you can see at the moment is their belt-driven version. They're fairly small. They didn't have this one operating. And then they also have their bigger Workbee. That's James in the background. I hope he doesn't mind me showing him. And they had it all in this box. They basically built this massive enclosure, Perspex and Perspex, pretty sure it's Perspex, and aluminium extrusion, just for the purposes of the show, because obviously a CNC machine is fairly loud, makes a whole load of dust and all that sort of stuff. So they wanted to seal it in so they could have it operating on the stand. Obviously, that's not necessarily useful in all applications, but they needed it just for the show, so they built it just for the show. So they had its CNC making the chessboard. They also had the 3D printer printing the pieces, although I didn't actually see that operating. But I've no reason to believe it doesn't work. I'm pretty sure it was a D-bot, just a very tall one. So one question that might be interesting for everyone here is, like, for example, having a CNC has this requirement, obviously, that you need a space that you can typically get dirty and you don't mind being loud. But this enclosure actually reduces the decibels quite significantly. So it'll be a lot quieter than it would otherwise be. I'm not saying you can then put it in your living room by any means, but I think Ooznest will consider actually creating these boxes for people to buy specifically for their machines if you're interested. So if you are, it's probably worth letting them know that you saw their box at TCT. Well, mention maybe that I pointed it out to you, whatever you like. Because I mean, if they get a lot of interest in these kind of things, then that's when they're gonna make something. What else was going on there? Oh, just for some of you that might not know who Ooznest are, they are a company in the UK, which is obviously why I quite like them, because they're, I mean, I say local, they're not based in the same area as me, but they're in the UK, and they basically make a lot of this open builds kind of stuff. So they, in the past, they've been mainly kind of CNC based, but they do sell quite a lot of 3D printed parts as well, and it's all based, well, mostly based around this open builds platform. So yeah, they sell kind of all sorts of stuff that's applicable. Now the new thing that they had is a filament range. So you can see in the background there, Ooznest materials. They're starting this kind of Ooznest materials range as not just filaments, but maybe this is kind of another bit where feedback I think will be quite useful for them. They've noticed over the years that when you have a CNC machine like this, it's not necessarily easy to get material in the size that you need. If this is all the space you have and you put a CNC in it, how do you get a sheet that's 12 by 4, 12 by 6, whatever it is? I think it's 12 by 4, 8 by 4, whatever. Massive sheets. You've got to cut them down before you can put them on a CNC bed. So I mean, it's things like that. It's just not necessarily that easy. So they're considering. Oh dear. Apparently the audio is terrible. Why is the audio should be good because it's, so 2 seconds. So where were we? Yeah, so here we go, the Ooznest materials range. You can see they're having a huge load of materials and also a huge range of colours. Now obviously a lot of these colours, like the unique colours, will be for the PLA, because PLA is not easy necessarily to make into lots of colours, but is the material that you'll typically find in lots of different colours. Is the audio still terrible? I'm being partly informed that it's in fact terrible when it should sound fine. Let me just check. There's nothing to suggest on my end that the audio would be terrible. Unless this is... I might just... can't do much about it now. Streaming audio bitrate. I can try increasing that probably. No, that's the limit. Well, we'll just have to deal with it. I'll try and improve it for tomorrow if I get some time. So yeah, Ooznest materials, there's a whole load to select from there, and they might be trying to work on some sheet materials like aluminium and plywood, probably stuff like that, that you can put onto CNCs just in format. So they're just trying to get you material in a format that's useful for you to be able to use. So again, if you're interested in that, by all means, let me or them know. So that was pretty much it for Ooznest. Very interesting talking to Ryan and James. They've got a lot to talk about. There's a lot going on at Ooznest. They've had a busy few months. They've obviously, I say obviously, they also have a new website. Well, not new today, but new recently. So if you've not checked that out, then go and have a look at that. You can probably just Google Ooznest and you'll find it. OOZNEST. Should be good. The next quick one was ColorFab. They had some pretty funky printers and a new material. So, I mean, I say new material. The material itself is not exactly new, but it was a new combination, or lack of combination, if you like. It will make a bit more sense when I show you. ColorFab. Okay. See how we... Oh, it's getting a bit confused. My colours here, on my photos here rather, came out really surprisingly well. Oh dear, is that the audio still bad? I don't know what I can do about it. It's using the best audio I have, I think.
Unless that's any better. If that audio is better, then we'll carry on with that. If that's not better, then I'll switch back to the other one. Oh, really much better. That's weird. So the inbuilt microphone on the Mac that's probably 15 years old is better than a Zoom H1. Interesting. It's probably to do with some compression or something that's happening in the device. Okay, well, we'll carry on with that then. No switching back. Let me, sorry. Hold on, have I had this the wrong way? No, that's right. Yeah, compression limited. I think it was pushing it in WAV and then just trying to over compress it or something. Anyway, I think we'll stick with this now. Apparently it sounds a whole lot better. Excellent. Okay. So what you're looking at here is the stacker printer. Now, I hadn't heard of it, but I think probably other people might have. It is absolutely enormous. I mean, this thing was standing on the floor and comes up to my chest, and I'm 6 feet tall, so did it come quite up to my chest? Maybe not quite, but it was enormous. You can see those 4 massive things being printed all at the same time. All those heads are obviously moving completely in sync. I don't know if they're locked to each other, but it's just a phenomenal piece of kit. It's absolutely huge. Not sure what this material was, but I don't think it was the new material. It might have been. So anyway, this new material, it was called PA something. I've written it down somewhere. I shall find it. Oh no, I've lost it. Oh no, where is it gone? PA Neat. So it's called PA Neat because it's PA, which is nylon, and neat because they've not put any additives in it. So I think they've had a colour additive, but maybe that's not classified as an additive. So the colour that they've put in it is black. So let's see if we can find. I don't know what that looks like your end, but I love that picture. It's turned out so well. Anyway, let's carry on. Just some more pictures of this absolutely enormous printer. Oh, there you go. Sorry, that image is on its side. As I said, not had time to edit these in any way. But hopefully that gives you some idea of scale of how enormous that printer is. Oh dear, more on the side, sorry. So this is the new material. This is PA Neat. Now it is a nylon and it is black. So why have they made it then? Well, obviously one is the black thing, but 2, nylon typically is not very easy to stick down. It's prone to serious amounts of warping. But this one, they've printed these things. These are PA. They can print these on a... I just remembered the thing. Sorry. They print these on a glass bed at 60 degrees Celsius. Now, it does also have a print sticking compound. I think it was 3D lac. Oh dear. YouTube's complaining again. Oh, come on. Video output low. I don't know if it complains the video output is low when I'm just showing a static picture. I've not dropped any frames, so let's carry on. So yeah, they've printed this on a 60-degree bed, and there was no warping, which is pretty amazing for nylon. Now, the downside of this is it does seem to have worse absorption properties, so it's even more hygroscopic than nylon normally is. So in terms of storage and even during printing, you need to keep this dry, basically, enclosed in a dry environment, and then dry it between prints probably. So it's fairly labour intensive, I would imagine, if this is something you want to keep using and use all the time, unless you have purpose-built machinery to do it. But as a concept, this seems like a really good way to get high quality material printing, well, high strength, from a fairly standard 3D printer, because you don't need like super expensive bed surface or massive enclosure or everything. I mean, these printers are completely open. So yeah, Pretty cool material. Again, I've got a sample of this, slightly bigger one than I got of the other little print. Who are we talking about? Colour Fab, yes. I've got a big black spool of it. I mean, it's probably 15 meters or something. It was impressive for batch manufacturing, absolutely. That machine is absolutely huge. I couldn't believe quite how massive it was. I don't know how they're keeping all those nozzles level and flat and everything, but whatever it is, it's definitely working well. And of course, Colour Fab have their RAL colours. So RAL is like, I don't know if it's specifically an automotive spec, but it's a RAL colour is, well, a RAL number is a way of specifying an exact colour. So they can basically make filaments to any RAL colour. So they had huge amounts of different colours on display. They were literally piled up to the, well, not the ceiling, because like the ceiling was 40 meters in the air, not that high. Anyway, it's getting late and I'm tired. It was piled high and there were a lot of colours, put it that way. Now, obviously I have no way really to compare that the colours are accurate necessarily, but it was quite cool that you could basically choose a colour and go, I want that, and they can make it. So that was good to see. Again, some more pictures of that 3D stacker. You can see all the tools attached to the back, so these are obviously in Bowden operation. All the extruders attached to the back and the hot ends along the front. I hope you can see these pictures as nicely as I can. I'm actually... I don't like to blow my own trumpet, but I mean, going around, this is the first time I've really tried taking photos at an exhibition show like this, because typically the lighting is not necessarily ideal. It could be all over the place. You can't even necessarily get to where you want to be to take the photos, so you're just kind of really kind of hoping for the best a lot of the time. So it's quite lucky when you get some decent ones like this. I think these are possibly looping. Yeah. So yeah, there was quite a lot on offer there. They were all very interesting. And now the super exciting bit, the bit we've all been waiting for. Let's go have a quick look. Let's change the slideshow. There were a couple of other stands that I did see today that we're not going to go through, because I think I probably need to have a little bit more information on them before we go through it. So this will be the last one for today. Now this stand was RepRap World. This is where I bumped into Richard Horn, which was quite nice to meet him. He's really pleasant. He's a really nice guy. So that was, yes, that was a really good experience. He had quite a bit to say about this as well, so I stood there with them and kind of discussed the upsides and downsides of this kind of extrusion mechanism. It's basically a high speed and high torque arrangement set up for 2.85mm filament, and they can feed that filament through using this machine. Well, the aim for the design is, I think, 2 centimeters per second, which that's speed of the filament, not speed of the nozzle. Speed of the filament, which is pretty ridiculously quick. So you can probably see there how you've got NEMA 17 motor at the bottom. You then have a gearbox that's probably built into the motor. That won't be, I don't think that was any of the RepRap World design. Did I mention this was RepRap World? This is RepRap World. This is the stand that I was looking at. And then on the top here you have this really strange looking arrangement where it's kind of this brass nut with printed parts holding what can only be described as razor blades. So the filament goes in, turns kind of 30, 40 degrees around this basically razor blade hobbed gear, and then gets pushed out the other side. Now, the downside of this, as Richard quite rightly pointed out, is that it absolutely brutalizes the filament. I mean, these razors cut in seriously deep into that filament, so you can get high torque, you can properly grip that filament really well. The downside is you probably damage it, and you will probably see those artifacts from that aggression on the filament in the actual print itself. Now, it's probably quite likely. I mean, the guys had done a fair bit of testing on this, but we didn't necessarily see that, so take it with a grain of salt. But they were doing the same. They were saying, for example, they've already tested some of these things, and although we were mentioning them, they'd already kind of proven them wrong, if you see what I mean. But my thoughts on it were that if you are using an arrangement like this, chances are you're trying to print high speed on a high flow environment. So something like a very large format printer with a very large nozzle, etc., etc., etc. So you need a lot of filament, and the quality of the very fine details may be slightly less important. However, if you were trying to put this on something like a Prusa Mark III or something of that sort of ilk, or maybe even on like a 0.2 nozzle or something, this is going to be going very slow, and you're going to almost absolutely certainly see the artifacts as a result of the cutting into the filament in the print. So while it may have a whole load of advantage in terms of speed and grip and all that sort of stuff, it's definitely not perfect, but it's pretty cool. I mean, this is really nice to see. It's something different. So somebody's obviously, I mean, they're trying to produce something that's different and better. That's obviously yet to be seen whether it will be better, but it's certainly really interesting. Now, the best part for me today was absolutely not that picture, because that's basically the same as the last one. This. So this is a control board by RepRap World that is going to be coming out at the end of October. It is a 32-bit control board. It has 4 outputs, and you can do 5 with an adapter board that they sell. It's USB control for your programming. It's basically exactly like a ramp, better. The stepper drivers are DRV8825. We definitely said DRV, don't know what the number, pretty sure it's the standard 8825. You've got a number of MOSFET outputs, and a bid MOSFET output has up to 10 amps. The board can operate from 12 volts, and in 12 volt operation that can also convert 5 volts for power to the board, or you can input 24 volts to control the main electronics, stepper motors, heater bed, etc. And then you have to power the 5 volts separately, so from just like a USB output, USB power, fairly standard. So that gives you some power options. And this thing is going to be coming in at £40. And I thought that was amazing. In my mind, if anyone has a ramps on their printer and they want something that's properly made, properly designed, safer, and not very expensive, and of course significantly more powerful, and have more options, all of those things, and it's 40 quid. That to me was epic. I think if you've got a ramps on your board, a ramps on your printer, you should probably consider, I mean, I've not tested it yet, but when this comes out, if you're looking for something as an alternative, you probably want to check this out. If the reviews are good, then that will be very interesting, because it was just amazing. And it was like proper Raspberry Pi board size as well. It's not huge. It just has all the functionality you need. Nothing over the top, nothing excessive. Just the basics done absolutely right. I'm pretty sure, don't quote me on this, but I think there was thermocouple measuring as well. I didn't get the name right. because I asked to take pictures of it. They were like, it's okay, we've got this extra sample you can take pictures of. So they put it down on this white cloth where I could take some better pictures that you can see now. But then by doing this, I forgot to take a picture of the label that said what it was. But this is from RepRap World, so keep an eye on their website. End of October, this is going to be coming out. I'm not saying go buy one. I'm saying make sure you check reviews, because it has a lot of potential. And at 40 quid, that's going to be mental. I think if things go well, the recommendation is likely to be that any ramps board have this swapped out. For £40, it's a no-brainer. It runs obviously Marlin firmware, so configuration-wise, it's going to be easy. And it's 32-bit control board. I mean, that's like computational power is like not even a concern. Core XY, Cartesian, easy peasy. I'm pretty sure they said 32-bit board at 400 megahertz, but I'm not totally sure. That's kind of from memory. I'm really excited about it, and hopefully you are too. But obviously, as I said, wait for some reviews and we'll see if it is indeed worth it. They're doing testing now, but they're in production and that kind of stuff, so things are coming along fairly nicely there. Right, so that's it for today. No Prusa or E3D yet. I have an E3D meeting tomorrow, so I'll be sure. I mean, that's the only meeting I actually booked for the whole of TCT, so hopefully I'll make it to that on time, as it is now 10:30. So yes, hopefully I'll get some more details on Prusa stuff tomorrow. I've got some about the SL1 and Filament at the moment, but I think we're going to wait on a little more detail on that. Otherwise, all looking very exciting. It's been quite an exciting day. There's been a lot going on. I've not really managed to tweet much. I kind of said I would, but I haven't managed to. I've just been trying to focus on talking to people, finding people, tracking them down, that sort of stuff. Anyway, thank you very much for watching. I'll hopefully do another one of these tomorrow evening with my findings from, what day is it tomorrow? Wednesday? Wednesday at TCT. I don't know how we're going to do Thursday, because I'm going to be driving back home, so I might be able to do it when I get back, but that might be really late, at which point I will be properly shattered. So Thursday's one might be Friday evening, or something like that. Or I'll leave earlier and we'll see how we go. Anyway, thank you very much for watching this one. Good to see you all, and I will see you in the next one. Goodbye.